Welcome to the webinar again. Thank you for joining today. My name is Ken Sloat, and I'm an R&D and technical sales engineer here at Variscite. Today I have with me Jay White, who's a senior marketing manager at NXP. And today we're going to be talking to you about creating a new generation of IoT with Variscite's NXP enabled Wi-Fi 6 SoMs. So before we get started, I'd like to talk a little bit about our agenda today. So we're going to begin the presentation with the NXP portion. Jay is going to be talking to you about the evolution of Wi-Fi, what is Wi-Fi 6, the market segments that benefit from Wi-Fi 6, and along with NXP's IW612 Wi-Fi 6 solution. Following that, I'm going to talk a little bit more about Variscite, who we are and what we do, along with our new Wi-Fi 6 based SoMs. And then following that, we're going to have some kind of hands-on demos actually walking through how you can somewhere where you can enter in questions, and I encourage you to get those in early, as the presentation is ongoing, so we can address as many as we have time permitting at the end. So with that, I'm going to hand it off to Jay to start talking about Wi-Fi 6.
Well, thanks, Ken. I appreciate it. And thanks, everybody, for joining today. I'm really excited to be presenting our Wi-Fi solutions in conjunction with Variscite, who's one of NXP's platinum partners. So being a platinum partner with NXP means that we are tightly coupled between Variscite and NXP on delivering solutions that really solve customer problems. We relay information back and forth to each other. We help with roadmap decisions. And it's just such a great relationship that we have between Variscite and NXP. So I'm happy to be here and talk to you today about our Wi-Fi solutions. Now, before we get started, I wanted to discuss a little bit about NXP and what we are doing to empower the edge, is what we like to call it. So the way that we empower the edge is by offering a broad portfolio of connectivity and processing products that address the edge computing needs of today. So we do that through a broad range of MCUs and MPUs. We're combining those platforms with connectivity such as Wi-Fi, Bluetooth, Thread, 5G, and others, coupling that with security to, again, empower the edge for things like home security, smart appliances, industrial applications within healthcare, power and energy. And we're creating solutions to address these types of applications. Next slide. Now, one of the ways that we're empowering the edge is we're investing heavily in our platform architectures. And what I mean by that is, again, we're taking the platforms, the MPU and the MCUs, we're doing all of the things on the back end to help from an integration standpoint. So from a Wi-Fi and Bluetooth perspective, one of the ways that we're creating a common platform architecture is we've taken our Wi-Fi products and we've integrated the software, the drivers and the firmware into the Linux BSP, for example, for the i.MX 6, 7, 8, and 9 families. So this helps with connectivity out of the box, especially when you're using one of Variscite's SoMs. It helps get connectivity up and running very quickly, and we continue to support these products for the longevity of the product. Next slide. Now, Wi-Fi for the industrial IoT. Wi-Fi is an important mechanism within the industrial space. And I say that because Wi-Fi is one of the most ubiquitous connectivity mechanisms in the industry. It provides a flexible architecture for customers to leverage. So it gets rid of all the cables and the wires from the floor, which could be, potential safety hazards. I mean, I've seen deployments where there's cables strung across the floor, and maybe you're using some of the little rubber things to cover them up, but it definitely creates a lot of issues from a deployment standpoint. So having a Wi-Fi solution allows more mobility, it allows more flexibility within the environment, and it gives you a much better communication mechanism for these devices that, again, are mobile in nature. Wi-Fi is also a scalable solution. It's a great choice for a large, dense deployment of devices. It also helps with coexisting with other radios as well. So as much as I love Wi-Fi, there's other connectivity types out there as well that serve different purposes. And one of the things that we do within NXP is make sure that our radios work seamlessly with these other types of connectivity offerings. And last but not least, Wi-Fi is an affordable option for the industrial IoT. When you is very expensive to operate on. You have to buy the data or you have to buy the spectrum to be able to operate on it. Whereas Wi-Fi is leveraging unlicensed spectrum, which is free to use, and they're opening up additional spectrum globally with the 2.4, 5 gigahertz, and now 6 gigahertz frequency bands. So it's a great option that allows for a good, affordable solution. And when you look at those things, it's a good ratio from performance to cost. Now, Wi-Fi's evolved over quite a long time. Starting in the Wi-Fi, it was all about just getting the connectivity to be reliable, to become a reliable cable replacement solution. Back with Wi-Fi, we'll call it 1, 2, and 3, which is 802.11 A, B, and G. But it was really just basic connectivity. As connectivity evolved, with Wi-Fi 4 and Wi-Fi 5, these were really focused on individual device performance. And what I mean by that is we were always trying to see how fast can we make an individual device on the network perform. And that was great on the early days of Wi-Fi when there weren't many Wi-Fi devices connected to a network. So if you only had a gaming system that was running over Wi-Fi, you wanted potential pitfalls is when you have dense deployments of devices all trying to operate as fast as possible. And what we ran into is a lot of efficiency issues by trying to make all the devices perform quickly. And so what we're seeing now with Wi-Fi 6, Wi-Fi 6E, and moving forward into Wi-Fi 7 is a real focus on how do we make the entire network perform better. Not just the individual device, but all of the devices on the network. And so there's a large effort with Wi-Fi 6. We'll get into some of the ways in which they've done this, but to create network efficiencies that improve the overall device performance or the overall network performance. Okay. So what is Wi-Fi 6? Let's take a quick peek here at some of the mechanisms that are driving Wi-Fi 6. Now we talked a little bit about the generational changes between Wi-Fi 4, 5, and 6. This slide has a bit of technical detail on it, but a few of the things that I wanted to outline. One, the modulation scheme used with Wi-Fi 6 is different than that used with Wi-Fi 4 and 5. We're now using OFDMA, which is a much more efficient modulation scheme that can deliver better performance using the same frequency. Another thing is the subcarrier modulation. It's kind of towards the bottom. But with Wi-Fi 4 and Wi-Fi 5, we saw 64 QAM and 256 QAM. This is essentially how much information, how much data you can pack into each transmission from Wi-Fi. And now with Wi-Fi 6, we're seeing 1024 QAM, which means that we have essentially 4x what we used to do with Wi-Fi 5 into Wi-Fi 6. So each transmission contains more information, which means that we can send less packets, less on-air time, and promote better efficiency overall. Next slide. So go ahead. I don't know if you can get to the next slide. There we go. So with Wi-Fi 6, so how do we really create some of the efficiencies that we're talking about? How do we get some of that performance out of the radio? Well, these are the key features that are implemented with Wi-Fi 6. And I'll just touch on them very briefly because we could spend a whole webinar just on some of these features. But again, so the ways that we're promoting the efficiency is through a few things. One is uplink and downlink multi-user MIMO. So multi-user MIMO is important because it means that we can service multiple devices simultaneously, whereas previous generations of Wi-Fi, like Wi-Fi 4, even some of the Wi-Fi 5, we had to service each client separately. So if you have 10 devices on your network, it would take 10 different transmissions to service those devices. Whereas with multi-user MIMO, now we can service groups of devices simultaneously, which again reduces the amount of on-air time needed, promoting better efficiency. Another way that we're promoting efficiency is with BSS coloring. This helps with spatial reuse. So now we can better leverage the spectrum that's available and make sure that we're preventing other collisions or coexistence issues with channels that are next to each other within the network. 160 megahertz wide channel bandwidth. This one's important for performance. So this is like adding additional lanes to a highway. We're increasing the channel width, which allows us then to send more information much faster down the network. So this is great when you have devices that need high performance, need gigabit speeds over Wi-Fi. OFDMA is a very important piece of Wi-Fi 6. This is a new modulation scheme that improves the overall efficiency of the transmissions. So again, this kind of goes back to taking OFDMA, using that with multi-user MIMO and BSS coloring to promote overall spectrum efficiency, which increases the performance of all the devices on the network. And we did talk about 1024 QAM as well, which is important for sending the transmissions. But all of this adds up to better capacity, so you can have a dense deployment where all of the devices in the network are operating much more efficiently, much more, much better together. The efficiency of Wi-Fi 6, which is great for specifically power consumption. Things like target wake time, where you can have a device go to sleep for longer durations without being kicked off the network. This is great for sensor type devices. It's great for devices that maybe don't send a lot of data, but need to spend a lot of time sleeping. Wi-Fi 6 implemented this new feature of target wake time to be able to keep devices asleep for longer durations of time. Overall performance gets better as well. Even though there's spectrum efficiencies and total network performance increases, individual devices get better performance as well, with higher data rates and much faster throughput speeds. So again, Wi-Fi 6 is such a generational change for Wi-Fi. It's really moving the wireless connectivity standard forward. Next slide. So what are some of the market benefits or market segment benefits from Wi-Fi 6? Let's take a look here. Wi-Fi 6 really benefits a lot of industrial applications. It benefits industrial applications because we talked about the reduced latency, the better network performance, the dense deployments. So it helps from a capacity standpoint, where now we have more wirelessly connected devices within a factory, within an industrial setting. Wi-Fi 6 helps all of those devices operate better together. We're seeing better efficiency, which helps with Wi-Fi in the industrial applications as well, because some of these devices don't necessarily have to stay connected all the time. And so as we can reduce the power consumption, we can create devices that have smaller batteries. And again, it helps from a power standpoint. Performance and data rates are also extremely important for Wi-Fi 6 within the industrial space, because now we can have a faster transmission. It means that response times are going to be faster. We can get the data back to our backend network, so the cloud faster. And this again is extremely important for industrial applications that rely on quick speeds and low latency. So some of the areas that again help with Wi-Fi 6, we see a lot in the smart home. There's definitely a lot more proliferation of Wi-Fi within the smart home. But as we look at industrial applications, things like building management, automation in factory machinery, and even in medical is a great area where it's extremely important to have a robust connectivity solution in the medical space that can improve things like patient care, or can improve the overall experience for patients within a hospital that are maybe streaming devices, or maybe they're connected up to different medical equipment. Having Wi-Fi 6 can help improve overall patient the patient experience. Next slide. So it wouldn't be a webinar if I didn't touch on a little bit of our products. So I'd like to talk about our IW612 solution. We're really excited about the IW612. This is NXP's first tri-radio SoC. It's combining Wi-Fi 6 with Bluetooth 5.2, as well as 802.15.4. And why this is important is we see a lot of applications, especially within the industrial space, where you need Wi-Fi for fast transmissions, large data packets, and things like that. We see Bluetooth as being used either as a sensor network or maybe for provisioning of that device. And we're also seeing 802.15.4 from an interoperability standpoint, both with Matter and the smart home, but then also legacy deployments of 802.15.4 within the industrial space. And so by combining those three different radios into a single chipset, we can create a solution that caters to a broad range of connectivity requirements. Because we've put these three radios together, we spent a lot of time on the coexistence of these three radios to make sure that these radios can operate independently and concurrently without any kind of interruption, without any kind of collision or interference. We've actually taken an additional step. And so even though we have three radios on this chipset, we actually have a packet traffic arbiter and a coexistence mechanism for a fourth external radio. So if you wanted to add UWB or LTE, maybe another 802.15.4 radio, you can use the coexistence within the IW612 for that external radio as well. One of the areas that NXP really accelerates in is with our security. We took a look at this chipset from the ground up, and we implemented security at the very low levels. So this is one of the first chipsets in our portfolio that supports Secure Boot right on the chipset. And this is a separate Secure Boot implementation that you'll see on the platform itself with our i.MX 6, 7, 8 processors. So this prevents unauthorized access, it prevents unauthorized software from being loaded, and it adds yet another layer of security into your device, which provides ease of mind. Next slide. Here's a little bit more detail on the IW612 solution. Again, Wi-Fi 6, 1x1, Bluetooth 5.2, as well as 802.15.4. And all three of these are separate MAC and PHY implementations. So it's like having three radios side by side, all of which can be controlled, again, separately or independently, based on whatever your requirements are. A few things I wanted to point out. We spent a lot of time on this particular chipset making sure that we have great RF performance. And this translates to a better user experience and better performance for your devices. To perform within the industrial space. Same thing with the Bluetooth and 802.15.4 radios. We spent a lot of time really making sure that these are quality products and quality solutions that help, again, not only provide a better Wi-Fi experience, but a better user experience within that device. Next slide. So to conclude my section, NXP is, we're connecting the world. We do that with a broad range of connectivity products coupled with our platform solutions. And we really wanted to create a quality product offering, a quality platform offering to our customers. And again, we're really happy to be working with Variscite. Variscite's taking that to the next level, creating platform solutions using NXP components that you can use in your end devices. I'll let Ken talk a little bit about that more here coming up.
All right, thank you very much, Jay. So now we're going to transition to the Variscite portion of this presentation. Next, I'd like to talk a little bit about Variscite, who we are, what we do exactly. So Variscite is a leading system on module provider with 20 years in the SOM market, and we have an extensive customer base and pipeline. While many other SOM vendors use contract manufacturing facilities, we actually have our own state-of-the-art PCBA production facilities. And this ensures that we have complete control over the manufacturing process. As Jay mentioned, we are also an NXP Platinum partner, which allows us better lead times as well as early access to NXP parts, software, and tools. And in that role, we also provide the most diversified i.MX based product portfolio available to date. Our high quality standards meet even the strictest regulatory requirements, so that includes the medical ISO 13485:2016 standard, and we are also ISO 9001:2015 and ISO 14001:2015 certified. Additionally, we have an ecosystem of partners in order to offer a complete end-to-end solution for our customers. So at Variscite, we offer several key advantages. To start off, most of our SOMs fall generally into two families, the VAR-SOM and DART families. And these are generally pin-to-pin compatible within each family. And I'll explain some more about that on the next slide. While other SOM vendors in the marketplace might only stock 3 or 4 variants of a SOM, we actually offer the ability with any of our SOMs to fully customize individual features like memory size, CPU core count, eMMC size, etc. Many other on-SOM peripherals. So a lot of flexibility there for our customers. Our 100% yield performance ensures that everything is tested and validated before reaching a customer. So our customers can rest assured that the SOMs they will receive will be high quality and fully functional. Additionally, we provide production-ready hardware and software that has been tested and used by hundreds of customers. It therefore has proven high reliability and low risk. This, coupled with the free support that we offer our customers, allows an acceleration on their path to production. Additionally, with a robust longevity of up to 15 years, our customers can rest assured that we can continue to supply them throughout the life cycle of their product. So, as I mentioned before, Variscite has 2 major families of SOMs, the VAR-SOM family, which is on this page here, and on the next slide, I'm going to show the DART family. So generally, the difference, major difference is the DART exposes some more interfaces from the SoC. And as seen in the chart here, these are all pin-to-pin compatible. So that means you could actually start with VAR-SOM MX93, like we'll be talking about today, and scale up to something more powerful that suits the needs of your design. So this allows you to scale without redesigning your carrier board, and I'll talk more about this in slides to come. So like before, this is just showing the DART family of devices, and again, within the DART family, pin-to-pin compatible. So the pin-to-pin ability, scalability, not needing to redesign the carrier board in order to scale, optimizing cost versus performance. So for example, if you found that a particular SOM was maybe overkill for your design, you could even scale downward. Also just the ease of development and integration in the final product. And this also all offers a lifetime extension because of the pin-to-pin compatibility. So we already talked about the 15-year longevity, but this actually extends that because it means that, as we have newer SOMs that come out in the future that are in this pin-to-pin compatible family, it gives you even more options down the road. So now I've talked about Variscite, let's talk a little bit more about our Wi-Fi 6 based SOM. So I'm pleased to introduce our Wi-Fi 6 solution. Integrating the IW612 module that Jay was talking about. So this is our VAR-SOM MX93. This is available today. So just some basic specs about this SOM. This has got a dual Cortex A55 along with an embedded M33 coprocessor. There's a AI machine learning engine within it. It's available to be ordered with up to 2 gigabytes of DDR4 and up to 128 gigabytes of onboard eMMC, dual Ethernet, USB, and CAN bus, camera inputs, the Wi-Fi module, obviously with the Wi-Fi up to Wi-Fi 6 technology and Bluetooth 5.3. There's also an optional 802.15.4 radio that's an ordering option. It's got a 2D pixel acceleration engine, can be ordered in up to an industrial temperature range, and as I mentioned, 15-year longevity, and a member of our pin-to-pin family. So just looking out at what's available now versus the Varsum MX93 available today, and in design to include this Wi-Fi 6 module is going to be Varsum MX8M Plus, Dart MX8M Mini, and the Varsum MX8M Nano. Again, these are all pin-to-pin compatible, so even though the ones in the lower part of the chart are still in design, you could get started with Wi-Fi 6 today on our Varsum MX93 in our Symphony development platform, and then as soon as the Wi-Fi 6 becomes available on one of the other SoMs within the Varsum family, you can switch to that. So another major advantage to using Variscite SoMs is, with Wi-Fi 6 is easy upgrading, as I've talked about, not requiring redesign, not requiring you to redesign a carrier board. But we're also responsible for integrating all the hardware parts of this. So all the Wi-Fi 6 needed hardware, as well as software, which can be extremely complex, we've integrated that. So there's a lot of software patches that you normally might have to apply to your Linux kernel in order to support a Wi-Fi module properly. And we've gone through the legwork of doing all that and providing this in our base software releases, which I'll talk about next. So that gives you a jump start to be able to just start using Wi-Fi right out of the box. So next, I like to talk about the software that we offer in order to support all this. So here's all our Linux-based offerings. So the demos that I'm going to do today are actually going to focus around the Octo project, Mickeldor release. However, this same exercise can be completed on our Debian release for the MX93. And then in the near future, we anticipate supporting boot to Qt and Android. And again, this is not just common to the Varsum MX93, but as we support those other SoMs that I showed, it's the same kind of ecosystem. So we generally support these same operating systems on all our SoMs. So this is like not just scalable in terms of hardware, but also in terms of software. So what we're looking at here is our Variscite wiki that I'd like to touch on. So this is at verawiki.com. So you can go there and you'll see a big list of all of our SoMs, and you can click on any one of the SoMs, and what it's going to present you with is individual releases. So let me laser pointer here. So you can see the Mickeldor release. I can click on the developer's guide. It's got release notes, but I can click on developer's guide, and it takes me here to actually very extensive guides on how to build and customize the software, as well as individual interfaces like the Wi-Fi we're talking about today, Ethernet, display, very specific guides, along with commands that are specific to the release at hand. So what that means is that you can almost copy and paste a lot of commands without needing to modify them and get things working very quickly. And this is extremely advantageous because maybe you're new to the embedded Linux world, and that's a big advantage of using a SOM with Variscite, is we provide all of this base to start with to get you started very quickly on designing your product. So next, we're going to go through, run through some demos to show with the Varsum MX93 in our Symphony development platform, how do you actually get started with Wi-Fi 6 and to show how easy it is. So just to show, we're going to start off with building an image. So this is all in our VeriWiki, all the instructions for this. So if you miss some of this or don't understand exactly what's going on, it's all the documentation is online. But I just want to show how easy it is to get started. So essentially, this is on my build PC, Linux machine. I just make a directory. I use the repo tool to call out a specific release. So in this case, it's MX93 Yocto Mickeldor release. I call the sync command, and then that's going to pull all of the needed items to my computer in order to build the Yocto release. So just showing the log here, but it's going to run for a while, and eventually it's going to be successful, and it's going to create our image that we need to flash to our board. So now these images are available online. Like we do upload all our major release images, but we have all the instructions here so that you can build it, and I'm showing how easy it is to get started here. So I've got the image here. There's more than one way to flash it. SD card boot is one of the easiest to get started, so we're going to flash it to an SD card. So I simply use the DD utility along with ZSDDcat to flash this to an SD card. So now I'm going to show kind of the first demo here. So what we have going on, we have two of our Symphony development platforms, each with a VAR-SOM MX93 installed in them. They've got the SD card that we just flashed essentially, so we just flashed two of these. And what we're going to do is we're going to set up the one on the left, we'll call it board A, as a Wi-Fi client, and we're going to set up board B as a Wi-Fi access point. Now we're going to start with Wi-Fi 5 here for the demonstration, just to show some comparison with data rates and such. And the way we're going to demonstrate that is we're going to use something called iPerf, which is generally used for like network performance. So we're going to set up an iPerf server on the access point and a client on the Wi-Fi client, and then it'll connect and do some data transfer for us. Yep, so let's get right into it. So what we're looking at here on the left, this is on our board. So this is a configuration file for host APD. So host APD is a Linux service that can be used to easily create an access point on a Wi-Fi device. So just to show some of the configuration for Wi-Fi 5 or the 802.11 AC standard, we set it to the interface. We specify IEEE 802.11 AC right here. And automatic channel, I'm in the United States, and we set up the SSID, which is what's going to broadcast, in this case, VAR AP Wi-Fi 5. Once we've created this configuration file on our board, for the demo, I'm going to disable Network Manager and reboot the board. And then when it comes back up, I'm going to call to start host APD. So that's actually going to start the access point. Then finally, I will create an IP address. I will set an IP address for this access point. So it's kind of like your router IP address, so that when we have the client board connect to this board, it'll be able to reach it. So now back on our A board or our client board, we're gonna set up the Wi-Fi client. So this is on the other board. I'm going to call NMCLI dev Wi-Fi list. So normally you get like a big list of all the Wi-Fi networks. I've just filtered that for the presentation here, but you can see on my board, we saw VAR AP Wi-Fi 5. So it sees the other board as an access point here. Then I can call another NMCLI command to connect to it. And I'm going to give it a static IP address as well of 1.100. So the access point board was 101, and this one is 1.100. You can see the link comes up, and then I run an iwdev wlan 0 link. We can see we're connected, and it's displaying these kind of bit rates, and these VHTs, they correspond to Wi-Fi 5. So it just shows we're connected in Wi-Fi 5 mode. So now we're going to show both boards. So on the left here, here's our client board. On the right here, that's our access point board. So boards A and board B. And we fire up a server with iPerf on the access point board, and it's going to listen for connections. And then on the client board, we're going to use an iPerf client to connect to 1.101, our access point. And then it's going to run a series of transfers. And then it shows us that we're, when I ran this, I was getting an average speed of around 50 megabits per second in my Wi-Fi 5 mode. So next year, we're going to be running essentially the same demo, but we're going to be using Wi-Fi 6 instead. So there's just going to be a little bit different configuration. And then we can see the performance gains that we get. So looking at the host APD config again, so everything's very similar here, except that now we've specified 802.11ax standard to enable, and we've changed the SSID for the demo to var AP Wi-Fi 6. And again, this is on our access point board, our board B, but same idea. You know, we've disabled network manager, reboot, and then we're going to start up host APD and give it an IP address. So now on our client board, just going to do the Wi-Fi list command again, and we can see now we've got var AP Wi-Fi 6 here. We can then add this connection to connect to that SSID, give it a static IP address once again. And then with the IWDev tool, we can see that we are indeed connected. And now if we look under the bit rates, we see the HE listed, which corresponds to Wi-Fi 6. So it's just kind of a way of verifying, like, yes, the module actually is connected in Wi-Fi 6 mode. And now we're going to run the same kind of iPerf test. So on the left, our client, on the right, our access point and iPerf server. And so after it runs the test, you can see, so previously I was getting around 50, and now I'm getting around 70 megabits per second average. And we're going to show how this really increases when we move to the next demo, which is going to be using a Wi-Fi 6 router. Yep. Ethernet link into a Wi-Fi router, and then on the left here we have the client again, but instead of connecting to the other board directly, it's going to connect to the Wi-Fi. So I've got the Wi-Fi client here connected to the Wi-Fi router, and then the board B is connected directly with Ethernet to the router, and then we're going to run iPerf between the two again. So the setup's a little different here because we don't have to fire up an access point because we've done that just with our router. That's the access point. But when I set up the router, I named it var router Wi-Fi 6. So you can see right here, this is on the client board, the Wi-Fi client. We're going to scan, and now we can see the router here, var router Wi-Fi 6. We connect to it. The command's a little shorter, you might notice, and this is because we don't have to set a static IP address this time. The router's just going to do that for us. It has DHCP. Then we use IW just to show we're connected, and you can see there's HE rates again. Again, the router is more capable here, so it's advertising some much higher theoretical rates for Wi-Fi 6. Now on the Ethernet client side, just showing I'm just obtaining my IP address because it did a DHCP to get the address from the router rather than statically set it, and so it's 0.175 this time. And then same setup before, we have an iPerf server on the board B, and we have an iPerf client on the board A, and we're just going to connect to the server, the 0.175, and it runs a data transfer rate test, and you can see we are getting significantly better data transfer rate at 340 or so megabits per second. So that's the end of the demo there. So as I showed, it's very easy and quick to get started with Wi-Fi 6 on our SoMs. Like I said, we have all the documentation to easily, quickly pull and build an image, and you can do this yourself and follow along through my instructions and get Wi-Fi 6 working today. So next, I'd like to transition to the Q&A portion of this. So this question would actually probably be for Jay, because I know Jay, you talked to me about this. Any support of the Matter protocol.
Yeah, no, that's a great question. So yeah, within the IW612, it is intended for Matter implementations. So our software does support Matter. We can use Matter via Thread or Wi-Fi with the IW612. That is part of our standard software release. Yep.
Thanks, Jay. There's another question here. Can the VARSOM MX93 act as both a station and access point simultaneously? And yes, it can. And in Linux, they actually expose separate interfaces. There's another question for you, Jay. Is there a free RTOS driver available for the IW611, IW612? I know we don't implement that.
Yeah, there is. So the IW612, actually the IW611 and 612 are both supported via the MCU Expresso SDK, which runs over free RTOS. So we do have RTOS drivers, free RTOS drivers via MCU Expresso SDK.
And which software releases is the new module supported on? So that for the VARSOM MX93, we're supporting this on Yocto Langdale, Yocto Mickeldor, and on Debian Bookworm. Someone asked, when will Mickeldor support low power mode? In terms of like low power mode on the MX93, we do currently support that. And then which kernel versions do you support for this module? So with our SoMs, with the releases we currently have, we support Linux kernel 6.1.1 and 6.1.22, depending which release you're using. And there is planned support in the very near future for the 6.1.36 kernel in our next releases. Okay, and I think that's all the questions that we have time for today. I want to just remind everyone, they can get more information by visiting our website at www.variscite.com or requesting that directly from our sales team at sales@variscite.com. Additionally, we offer free support for our customers through our support portal. So if you go to variscite.com/contact support, you can find out more about how to access that. Additionally, as I touched on the VeriWiki, extensive documentation there, so I encourage everyone to go there and take a look at a lot of the articles we have. And our software, this is all open source, so you can go to github.com/verigit today and start browsing through the code. And I want to thank everyone for joining again today, and have a nice day.